everybody. Happy April Fool's Day. I'm sure with an abundance of time at home with family, I'm guessing the April Fool's pranks will probably be pretty good this year and pretty inventive. Feel free to share some stories if you've done any good ones. Today we're going to take a look at calculating the volume of a rectangular prism. Whenever we're calculating volume of a prism or a cylinder, we can find that by doing the area of the base, right? So we're going to do that big B times the height. So in this case, a rectangular prism, our base is also a rectangle. I just kind of sketched it out for us there. So that's going to be length times width, right? And then we're going to multiply by our height. And that's our formula for volume of a rectangular prism. So length, I'm going to say, let's call 6 the length, which makes 2 the width, and our height is 10. So our volume is going to be 120, and volume is a cubic unit because we've multiplied centimeters 3 times. Centimeter times centimeter times centimeter is going to be centimeters cubed. On page 36 here, we're looking at our volume formulas. Remember, volume is the space a figure takes up or what you can fit inside of it. Yesterday, we talked about surface area, which was that outside area. Volume, what we're filling inside. Surface area, what we're painting on the outside. So we got our rectangular prism we did in the do now. Length times width times height, right? That's an L, that's an L. We can find the volume of right triangular prisms, and this is a formula I think we should go over, that the width and the height are the legs of the right triangle. That just means they're perpendicular to each other, that they're forming that right angle. When I'm using the formula, I identify the width and the height of the triangle by finding that 90-degree angle. And then our L, our length, I think of as the distance between the two bases. And our volume formula is 1/2 width times height times length, or width times height times length divided by 2, because really what we're doing there is taking our rectangular prism, slicing it in half, which is where we're getting our 2 right triangular prisms. Some of you might notice this S here. We call that the slant. That's not needed for volume. We use that if we're using a surface area formula for right triangular prisms, and that's something you'll look at in 8th grade. Okay. Then we've got our cubed, side cubed, and then our cylinder, which again we can see our base times our height. Pi r squared, that's the area of the circle. That's the base times the height. Okay. Either way we can use that. Even with our right triangular prism, when we look at that 1/2 width times height, or width times height divided by 2, that's the area of our base. Okay, so let's continue on to page 37 and put it into practice. Okay, so page 37, number 1, find the volume, show all work, formula, and labels. Now again, if you just want to find the area of the triangle and multiply by the height by saying, okay, 9 times 12 and divide by 2, and that gives us, let's see, 9 times 12 is 108, divide by 2, the area of the triangle is 54, multiply by your height, or in this case our length in our formula, times 18, you're going to get a volume of 972. I say though today, let's practice our volume formula. 1/2 length times width times height, and identify our information. The first thing we said was the width and the height are perpendicular to each other on the triangle, that they find that 90-degree angle, and there they are. So I'm going to call 12 the width, 9 the height. I could have done it the opposite way. So volume equals 1/2. Our length. Remember we said our length was the distance between the two bases. So that would be 18. So we're going to do 1/2 times 18 times our width 12 times our height 9. Now, some of you might be saying, well, what about the 15? We don't need it. Okay, that would only be useful if we were finding the surface area. That's showing this part here. Don't need it for the volume. Okay, so let's say 1/2 times 18 times 12 times 9. Like I said, 972 centimeters cubed. Okay, good. On to number 2. Find the volume, show all work, formulas and labels. Ooh, leave answer in terms of pi units. Yes. Now, on a quiz or a test, you're going to be allowed to have that formula sheet, so you don't have to worry about memorizing it. But like I said, that base times height always works. Volume of our cylinder, pi r squared h. Our 12 there, that's the diameter. So our radius is 6 as we substitute in. Volume is going to be pi times 6 squared times 10. So volume is pi times 36 times 10, or 360 pi. Leave in terms of pi units. We just need our units then. Centimeters cubed. 360 centimeters cubed. Okay. Number 3, we're still working with the volume of a cylinder. This time, though, we're given the volume, given the height, asked to find the missing dimension. So find the missing dimension for the given 3-dimensional figure, given the volume and other dimensions. Use the pi button on the calculator and round to the nearest tenth if necessary. So cylinder, we're talking about volume, so I'm going to write down our volume formula. Pi r squared h. This time we know the volume. The volume is 600 pi inches squared. So 600 pi is going to be substituted into volume. This is similar to what we did with our circle problems the other week. We've got 600 pi equals pi r squared, and we know our height, 30. Okay? So first thing I'm going to do here is I'm going to divide by pi, both sides. This way I get that out of the way first. Divide both sides by pi. They cancel because we were in terms of pi, otherwise we would have had to use our calculator. And we have 600 equals 30r squared. Now I'll divide both sides by 30 to isolate our variable. Oh, look. We should get 20 is equal to r squared. Now finally, we're going to take the square root of both sides to get what r is. So using my calculator, square root of 20, 4.4721, blah, blah, blah. Round to the nearest tenth, which is going to be 4.5. So 4.5 inches. Okay. Now, as we look at our work here, some of you might be saying, oh, well, couldn't you have divided both sides by 30 first instead of pi? Yes, I could have. Some of you might be saying, couldn't you have divided by 30 and pi at the same time? Yes, I could have. That all would have worked. Okay, so classwork for today, we're looking at pages 38 and 39. Make sure as you're doing your classwork, just like I modeled here in the notes, you're writing down the formula each time, then substituting in and doing your work or your solving. I expect to see both pages posted on Padlet. Today's math joke might require a little bit of explanation, but if you have an older sibling who has already taken Geotrig in high school, they'll get this one, so you can use it with them. What do circles and beaches have in common? They both have tangents. Okay, so here's why this one is funny. So tangents, like somebody who's tan on the beach, obviously. And then with circles, a tangent is a line that touches a circle at one point. Get it? Tangents. Circles and beaches, tangents. Have a great day, guys.